All right, so today we're working with our same properties, just on slightly harder problems. So let's take a look at this first problem. So there are x's in parentheses on both of these. What we want to do is we want to treat them kind of as two separate problems. So first, let's look at this problem right here. If I had just given you x to the third to the fifth, you would have had a power to a power, which means you multiply them. That would have been x to the 15th. What would you have had on the second half of this problem right here when you have x squared to the 8th? What would that simplify to? All right, you would have multiplied those, and that would have been 2 times 8 is x to the 16th. So now you have x to the 15th times x to the 16th. So if we look back at our page of properties, that is product of powers. They have the same base and they're multiplying, so we are going to add the exponents. So 15 plus 16 is going to be 31. So our answer is x to the 31. Okay, let's look at number 2. Number 2 also has a lot going on. I always like to look first and see if I can deal with any zero powers or negative exponents. So right here we have d to the 0 power. So d to the 0 power equals 1, and we don't have to write 1, so we can just essentially cross it out. And the reason we don't have to write 1 is if we have over 1, for example, d squared over 1, that's just d squared, so that's why we don't have to write it. Okay, now let's look and let's try to look at the same letters. So let's just look at b to the 5th over b. Okay, so if you think of that as a separate problem, b to the 5th over b, that's like b to the 1. You subtract them. 5 minus 1 is going to be b to the 4th. So you will have b to the 4th on top of the fraction. Okay, now let's look at the next letter. So let's look at c. So if I have c over c to the 7, that's like this. Think of c as c to the 1. C subtract the top exponent minus the bottom. 1 minus 7 is negative 6, so that puts it down here, c to the 6th, because the negative moves it to the denominator of the fraction. And then d squared, there's no other d, and so we can't do anything to simplify it. So our answer is b to the 4th times d squared over c to the 6th. Take each letter together as its own small problem and simplify, and then you just write them all together in the fraction. Okay, let's look at number 3. So we have h on top. We can't really do anything with that right now. So down here we have a power to a power kind of combined with, also at the same time, power of a product where we distribute. So we are going to take that squared and we're going to distribute it to the 4 and to the h. So 4 squared is 16. And then right here we have h to the 5th squared. So h to the 5th squared, you multiply them and you get h to the 10th. Okay, we have one more step to simplify because if you see here, we have 2 h's. So if we have 2 h's, we're not done yet. So this is, if you look back at our properties, the quotient of powers, where we are subtracting the powers right here. So this is where we are subtracting. So if you do 1 minus 10, you get negative 9. So what that does, if you get h to the negative 9 and you have 16 on the bottom, then the h moves to the bottom because of the negative exponent. We put a 1 on top to hold the place. Now I want to show you a different method of how I subtract on these. So when we have something like h to the 1 over h to the 10, you can just subtract in any order. So you can do 1 minus 10 and get negative 9, or 10 minus 1 and get 9. The key is where the bigger power is. So 10 is the bigger exponent. That's where the remaining h's are going to be. So picture this. H to the 1 is like this. H to the 10 is like this. So when one of them cancels out, do you see that all 9 are left on the denominator? And that's why you end up with h to the 9 on the bottom. So sometimes I just look for the bigger power and subtract them, knowing that the remaining of the variable, in this case h, is going to go either on the top or the bottom, depending on where the bigger power was. Okay, let's look at number 4. So on number 4, we have a negative exponent. There's no parentheses, so that negative 5 only goes to the y. So it only moves the y to the bottom of the fraction. So that's our correct answer. If it had been like this, to the negative 5, it would have moved everything to the bottom, and then we would have distributed the 5th power. But it wasn't in parentheses, and so that's why we end up with 8x over y to the 5th.